So hopefully the longhand addition, like the one on the left here you have on your sheet. Remember, when you do longhand addition, if there's decimals, you line up the decimals and you line up the place values, and you just add straight down. And you start to write. 4 plus 1, give me 5. 1 plus 7, 8. Drop my decimal down. 5 plus 5 is 10, so remember you carry the 1 to the next one. 1 plus 3 plus 5, 9. 2 plus 2, 4. 1 plus nothing, 1. You get 1,490 and 85 cents if you're talking money, right? So that's our longhand addition. Subtraction, again, we line up the decimals, we line up the place values, we just start subtracting. 6 minus 4, we get 2. 3 minus 2, we get 1, drop our decimal. But then when we have 1 minus 8 here, what do we have to do? You have to borrow from the next place value, right? So that becomes a 1. This would become 11 because there's 10 moved over. 11 minus 8, 3. 1 minus 1, 0. Again, I have to borrow here because I have 0 minus 1. So I borrow from that. That becomes a 10. 10 minus 1 is 9. 5 minus 0 is 5. 5 minus 0 is 5. So I get 55,903 and 12 hundredths. Okay. So that's our longhand addition, longhand subtraction. If you can do this, elimination will be very easy for you, okay? Because it's roughly the same thing. So look at the next two on your sheet. There are these two. We call these polynomials or systems of equations, multiple variables. You can add these together. You just line up the equal signs and you line up the numbers, the y's, and the x's. We call these constants, numbers without variables. So I want you to go ahead and add these together, subtract these. Add straight down, add straight down, add straight down. Same thing with subtraction, and then we'll check these. The nice thing here, though, you don't have to borrow. We can have negative coefficients on our variables. So take a second and try that. So like on the left one where you added 10 plus 1, you got 11. Here, this is 2y plus negative 3y. So how many y's do you have? Negative 1y, right? 2 plus negative 3, negative 1y. 3x plus 4x gives you 7x. So there I added those two together. One over here is subtraction. If I have 7 minus negative 1, it's minus a negative, so what's that going to become? It's going to become plus, right? So it would be 7 plus 1. That will give me 8. Negative 1x minus 4x. Negative 1 minus 4. So if I'm in debt 1 and then I take away 4 more, I'm in debt 5x's, right? And then if I have 5 y's and I take away 9 y's, I'm now down 4 y's. So I added those two polynomials or those two systems together. Right? And well, in this case I added, this case I subtracted. Yeah, question?
Wouldn't it be 8 or maybe the 6 from the bottom?
This one?
For the 8?
This?
Yeah.
Oh, because it's 7 minus negative. So you remember if you wrote that out, 7 minus negative 1, that would become plus, so it would be 8. Good question. Yeah.
Wait, wouldn't it be negative 3 because you're adding 4 to negative x?
Which one?
Right there.
This one?
Yeah.
That's negative 1 minus positive 4. Right? So negative 1, if I'm in debt 1x and I take away 4 more x's, I'm now in debt 5x's. Okay? So we added and subtracted these two polynomials together. This is what elimination is. I'm going to show you how it works or how you can solve variable in just a second. That next question there asks, what is standard form? And we just reviewed graphing and substitution. We'll come back to that later. But we're going to solve, graphing was the first way we did it, substitution was the second way, elimination was the third way. Still the same process. We're solving for x and y, or two variables. We just have a different method of doing it. Okay? So we've done graphing and substitution. Elimination is easiest when the equations are what we call standard form. So that next question on your sheet says, what is standard form? It's this right here. I'll write it bigger. It's called capital AX plus capital BY equals C. Now what does that mean? Okay, that means your x, this A stands for just the number in front of the x. Sometimes it's like a 2x or a 5x or a 10x or a negative 1x. plus, then you write your b. Sometimes it's a 2b, a 3b, or sorry, 3y, a 2y, a negative 5y. And then you write your equal sign, and then the number without the variable you put on the right side of the equal sign. So this is just kind of another form that we write our equations in. Just like slope-intercept form, we get y by itself. This is called standard form. Okay? We write the x, then we write the y, then we write the equal sign, and then the constant, or the number without the variable. So notice those two polynomials we did earlier, those are in standard form. It was the x, then the y, then the constant. Okay? The second one had the y, then the x, then the constant. But as long as they're lined up, that's okay. You always want equals and then the number without the variable on that side. Okay. So most of the ones we're going to do today are already in standard form. We'll see one or two examples without. So let's look at this system. This is the first one on your sheet. I want you to add these together. Okay. So we're going to write plus, just like it's a longhand addition problem. You add them together. Okay. And you can only add the like terms, remember. Luckily, it's already lined up for us in standard form. I would take 5 plus 7. That gives me 12. Drop my equal sign. If I have 1y plus negative 1y, what happens to my y's? I have 0 y's, right? So that's just 0. 0 times anything is 0. So my y's are gone. I have 0 y. So I don't need to write that. If I have 1x plus 3x, that gives me 4x. So now, is this an equation that you can solve for x? Yeah, you just undo that multiplication by 4 now, right? So to do that, I divide both sides by 4, and I get x is equal to 3. Done. There's one variable solved for. Okay. Now I need to go find a y. So I can take that x and I can either plug it in for x there, or I could plug it in for x there, and then solve for y. I'm probably going to pick the top one, because then I don't have to multiply by 3 and have a negative y. I'm going to pick this top one and go back and plug in x. So I have 3 plus y equals 5. Basically, I substituted, right? I substituted that 3 in for x. So now can you solve this equation for y? You can, right? Get y by itself, move that positive 3 to the other side, subtract both sides by 3, and y is 2. So the solution to this system is x is 3, y is 2. I added these two systems together. The y's became 0 y's, or they were eliminated. Right? I solved for x. Once I had x, I could take it, plug it back in. I could have plugged it into this one. I would have got 9 here, right? 3 times 3. I would have subtracted 9 from both sides. That would have been a negative 2. And then I would have had to divide both sides by negative 1 to get that y by itself, and I would have got positive 2. But it was a lot easier to plug it into this one instead. But you could plug it into either one once you have x. That's what elimination is. You add or sometimes subtract the systems together, and one of the variables is eliminated. Okay. Any questions with that first one? All right, let's jump to the next one. Here's the next one on the right. 4x plus y equals 7. 4x minus 2y equals negative 2. Now don't do this yet, but if I added these, look what would happen. Don't write this, but if I added these, I had 7 plus negative 2 would give me 5. 1y plus negative 2y would give me negative 1y. 4x plus 4x would give me 8x. Did that help me any when I added these? No, because none of the variables were eliminated. I still have both variables, right? But instead of adding them, if I subtracted them, would that eliminate one of the variables? I don't care which one's eliminated. I just want one of them eliminated. Let's try that. If I take 7 minus negative 2, minus a negative, give me positive 9. If I take 1y minus negative 2y, that's minus a negative, it's going to become plus. So 1y plus 2y is 3y. And 4x minus 4x is 0x. So that one is eliminated. So then I just solve this equation for y. I need to get rid of that multiplication by 3. Divide both sides by 3. 9 divided by 3. Y is 3. I have one of my variables. I need to go find the other one. So I can just take that y and I can go plug it in to either one of these equations. I'm probably going to pick the top one. Why would I pick the top one versus the bottom one? Yeah, it doesn't have a coefficient in front of it. I just plug in y there. So let's take this y and go plug it in right there. That gives me 4x plus 3 equals 7. And now I can solve this equation for x. Get rid of this addition by 3, or subtract 3 from both sides. That gives me 4x equals 4. And finally, I get rid of that multiplication by 4, divide both sides by 4, and I get x is 1, because 4 divided by 4 is 1. So you can either write it like that, or you could write 1 comma 3 as your solution. X is 1, y is 3. Okay. So in that case, I had to subtract them, because if I would have added them, nothing was eliminated. It didn't help me any. So sometimes you have to add them. All right, third one here. Okay. What are you going to do here? Would you add these or subtract these to get a variable eliminated? You would subtract these because it'll eliminate the x. Okay. So I do that. 4 minus 6, negative 2. 1y minus 4y, negative 3y. 3x minus 3x, 0x. That one's eliminated. So solve this equation for y. Undo that multiplication by negative 3. Divide both sides by negative 3. And instead of writing this as a decimal, I'm going to leave it as a fraction. Negative over negative is positive. So I'm just going to leave it as y is 2/3. So sometimes you get a non-integer answer. That's okay. That happens. Okay. So I now have what y is. I need to go find what x is. So I'm going to take this y, and I'm going to go plug it back into one of these equations. I'm going to pick that one, plug it in there, and then solve for x. So I'll write that off to the side. I have 3x plus 2/3 equals 4. I took this equation, I replaced y with what it's equal to. I need to solve this equation for x now. So I need to move this positive 2/3 to the other side. Just like if it was a positive 2, I would subtract 2 from both sides. I'll subtract 2/3 from both sides. That's eliminated. I'm left with 3x over here. Now on this side, when I subtract these fractions, what do you need about to subtract fractions? The same denominator. Very good. Yeah. You need common denominator. So common denominator between 1 and 3, both of those numbers go into 3, so I don't have to change this one. I just have to change this one. I need that to become a 3, so I have to multiply by 3. That means I have to multiply the numerator by 3. So that's going to be 12 over 3 minus 3 over 3. Or sorry, that's 2 over 3, the other one. I wrote that wrong, I'm sorry. 12 minus 2, 10. The denominator stays the same. So now I have 10/3. Finally, I need to undo this multiplication by 3. So I will divide both sides by 3. But over here, I'm going to write that as division by 3 instead of as a fraction. The reason is, remember when you divide fractions, it's the same thing as multiplying by what? When you divide fractions, what do you do to the second fraction? You flip it. It becomes its reciprocal. It's the same thing as multiplying by its reciprocal. So that means you flip it and change it to multiplication. Right? When you divide fractions, you flip the second one, it becomes multiplication. And then you just multiply straight across. 10 times 1 is 10. 3 times 3 is 9. So x is 10 over 9. You could change it to a mixed number. I would just leave it as improper fraction. Okay. So that one's just a little more work because I dealt with some fractions, but the process was the same. I still subtracted these. Okay. Sometimes you get a non-integer answer. That's okay. Questions at that one? All right. Try this one, and I have multiple choice solutions. So see if you can get an answer to this one that matches one of these. I'll give you 3 or 4 minutes to try that.
So how do you know if it's...
So first, was it addition or subtraction you had to do to get elimination? It was addition, right? Because when you add them together, negative 2 plus 17, if you're in debt $2, you add $17, you now have 15. If I have negative 3y's and I add 3y's, that's eliminated. That becomes 0y's, right? And then 2x plus 1x gives me 3x. Solve that equation for x. Divide both sides by 3. X is 5. So hopefully this is going to be my answer, but let's see if we can get 4. Okay. So I have x is 5, so I can either take that x and I can go plug it back in here and solve for y, or I could go plug it back in here and solve for y. I'm going to go ahead and plug it in this one this time. Okay. So if I plug it in there, it gives me 5 plus 3y equals 17. Now solve this equation for y. I have to move that positive 5 over to the other side first before I undo that multiplication. So I'll subtract 5. That leaves me with 3y equals 12, 17 minus 5. And then get rid of that multiplication by 3. Divide both sides by 3. 12 divided by 3, y is 4. So it would be, there's my answer, 5, 4. If I graph these, they would intersect at 5, 4, right? But putting them in slope-intercept form is a lot more work than doing elimination right here, right? Okay. Any questions with that one? No? Feel pretty good about it? Is it easier in substitution or graphing?
Yeah.
I think so. Some people prefer one or the other, but on assessments and stuff, you get to choose whichever one you want to use. All right. Last one here. Last one that's written out. And I kind of wrote it here, but what's different about this equation, these two equations, than the other two? Right, it's not standard form. It's not x then y equals the number. This one is, right? That's x then y equals a number. So I need to put this one like that. So I need to move this minus 2x over here. I'm just rearranging the equation. So since it's a minus 2x, I'll add 2x to both sides. So that top one then becomes y plus 2x equals, I'll write it underneath here, y plus 2x equals 7 because that's gone. But even this now, see how they're not lined up? My constants are lined up, but my y is lined up with my x lined up with my y. Just flip them. You can flip them as long as you keep the sign in front of them. Luckily, they're both positive, but this is a positive y, this is a positive 2x, so I can just flip those and make it a 2x plus y. And so I rearranged that equation, now I have that. So do you want to subtract here or add here to eliminate a variable? Let's subtract them, right? Because that's going to get the y's to be eliminated. So let's subtract them. 5 minus 7, negative 2. 1y minus 1y, that's going to become 0y, so that's eliminated. 4x minus 2x, 2x. And solve that equation for x, get rid of that multiplication by 2. Divide both sides by 2. And x is negative 1. Now, I can take that x and either go plug it in here or here to solve for y. Really doesn't matter in this one. They're both probably equally the same difficulty. So let's just say I'll pick, I don't know, the top one. If you pick the bottom one, you should get the same thing. Let's just say I pick that one. That becomes 4 times negative 1, right? Because that's what x is. So that's negative 4 plus y equals 5. And then get y by itself, move that negative 4 to the other side. Add it. Y is 9. Would have got the same thing if you did it here. This would have been negative 2 after I plugged in x, right? Add 2 to both sides. 7 plus 2, I would have got y is 9. Okay. So it doesn't matter which one you pick to plug it back into. Either one will work. Any questions there? Feel okay about this so far? Good. Now the last one, though, it says find two numbers whose sum, which means what operation? What's sum? Addition. That add to be 18, and whose difference, what's that mean? Difference is subtraction. Product is multiplication. Quotient is division, right? So who add to give me 18, subtract to give me 22. I want you to take like 2 or 3 minutes, try and guess and check and see if you can find those two numbers. Don't shout them out if you can't, if you got it. Take like 1 or 2 minutes, try and guess and check. It's probably going to be pretty difficult, but see if you can do it. So some of you may have it, but it's kind of hard to guess and check like that, right? But a couple of you got it, right? Good. But the easier way is just to set up 2 equations and solve by elimination, right? So this is 2 numbers. Let's call those numbers x and y. I want them to add to be 18. So one equation is going to be x plus y equals 18. Those are my two numbers, right? X is one number, y is another number, whose sum is, remember anytime we see the word is, it's equals, is 18. And whose difference, that means subtraction, is 22. Now can you find those two numbers by using elimination here? You can, right? But this one doesn't matter if you add or subtract here. It doesn't. Because if you add them, the y's are going to be eliminated. If you subtract them, the x's will be eliminated. So you could do one each way and just solve for both for x and y, or you could just do one or the other and then substitute back in. Let's say we're going to add them. If you do subtraction, that's fine. Go ahead and do that. 18 plus 22 gives me 40. 1y plus negative 1y gives me 0y. That's eliminated. 1x plus 1x, 2x. Solve that for x. Divide both sides by 2. So one of the numbers is 20. 40 divided by 2, I got 20. So to find the other number, I can either take that x and go back and plug it in here, or I could go back and do elimination again, but I could subtract. I could find the other variable. Let's say we went back and plugged it in. So I plugged that x in for 20. I get 20 plus y equals 18. Solve for y, subtract that positive 20 to the other side. Y is negative 2. Then let's check our answer. If I add those together, 20 plus negative 2, I get 18. If I subtract them, 20 minus negative 2, that minus and negative become a plus, would give me 22. So you can set up a system to solve similar problems to this. If you have two numbers, just call them x or y, write your two equations, and then try elimination to solve.